Hey guys, welcome to our first lesson on linear relationships. Linear relationships just meaning straight lines. So we're going into graphs, simultaneous equations, and all that good stuff. So let's get into the first lesson. This will be in-depth notes on linear functions. So let's start off. What is a linear function? You may have been familiar with this thing before, y equals mx plus c or b. In this, we have m is the gradient, right? And then b is the y-intercept. We usually call it y-int. You can see here and here. These are the two important ones, right? Gradient just means the slope of the line. So if we have a graph like this, right, this would be a very steep gradient because the slope is very steep, and this would be a very not steep gradient, we could say, because it's very small, right? Easy. And then we have here y-intercept. So this here, right, is the y line, right? It's just the point where the line crosses this line here, and that's the y-intercept here, right? So let's get into some definitions, right? We've got a linear function, which is this. We've also got the variables, right? So independent and dependent variables. I wouldn't recommend just memorizing, oh, this is dependent, this is independent, right? Just kind of develop your common sense, right? And this will be a lot easier. You've also got your gradient, slope, which is what we've done here. That's equal to either rise over run or y1 minus y2 over x1 minus x2. Got our y-intercept, gradient intercept form, and parallel lines as well. Parallel lines, right, if they have the same gradient, they're going to be parallel, just as long as they don't have the same y-intercept. So what does parallel mean? It means two lines that's right next to each other, and they'll go on forever and never touch, right? So this line and this line, if they have the same gradient, they're going to be parallel, right? So let's get into some questions on this. So if we're graphing these linear equations, we're going to use these steps. 1, construct a table of values. 2, plot the points. 3, draw the line. And then 4, determine the gradient and y-intercept. So let's get into some of these. So 1, graph the function of y equals 2x minus 3. Right? All I'm going to do is draw a table of values. Usually you just need 3 points. So let's put x and y, right? -1, 0, and 1 here, right? And then in our calculator, right, we just sub x for one of these values here. So y equals 2 times -1 minus 3. That is 2 times -1 minus 3. That's -5. Right, and then the next one, we put 0 in. That's -3. The next one, we put 1 in. Right, that's -1. Right, and so if we draw a graph, here, it's here, right, this being your x and this being your y. We put the points in, so -1, 0, 1. Going down here, we have 5, 4, 3, 2, 1. -1, -2, -3, -4, -5. And then we just plot the points in. So at x of -1, so here, right, we have y of -5. So if here, right, when x is equal to 0, y equals to -3. When x equals to 1, y equals to -1. So that's here, right? I'll just do another point just to make this a bit clearer. So if we put 2 here, it's going to, and draw this, it's going to equal 1. Right, so 2, we have 1. Right, and then we just draw a straight line to really intercept these. Obviously, you'll use a ruler. I'm just going freehand for now. Right, draw an arrow, and then put the equation. So y equals 2x minus 3. And that's our linear equation done. Right, let's do another one. Let's have this graph. So again, step 1, draw a table of values. So minus 1, 0, 1, x, y. And then we're literally just subbing, right, x for whatever x value is here. So if we have y equals minus 1 over 2 times minus 1 plus 4, right, and then we just plug these in. So minus 1 over 2 times minus 1 plus 4 is equal to 4.5. We have 0, that's equal to 4. And then we have 1, which is equal to 3.5. Right, we draw this out. Make this a bit bigger. Minus 1, 1, 5, 4, 3, 2, 1, etc. And then we just plot the points. So at minus 1, we have 4.5, which is here. 0, we have 4. And 1, we have 3.5, which is here. Draw a line through. All right, draw an arrow and the equation. So y equals minus 1 over 2 x plus 4. Right. One thing you should notice with this is that this gradient, right, if it's negative, right, it means it's sloping downwards. So a negative gradient is going to go like that. A positive gradient, right, if this is positive, so, you know, for example, up here we have 2x, it's going to slope upwards like that, right, up to the heavens, right, positive heavens, you know, stuff like that, right. You'll also notice that this gradient is just showing how much it goes up or down by each time. So through each step, so we go up, every time we go up by 1, right, this gradient decreases by half, right, as we can see here, decreases by half, right, easy. Let's do the next one, finding the equation of a line using the points and gradient form, or gradient point intercepts formula, right. This is important. This is what a lot of people forget in the HSC, and it leads to them losing marks. So we just need to remember that we're only going to find values for these things here, these 3 values. Find values, right? So the question will often be like this, right? It'll give you a gradient, right? And then it'll give you 2 points that are on that line, or maybe even 1 point, right? And you have to find the equation with that. So let's get into this example. Find the equation of a line with a gradient of 2 that passes through the point 0 and 1. So if we have this formula, mx minus x1, right? All we have to do is sub in the numbers. So y minus 0, or minus 1, I should say, because this is x and this is y, right, equals 2 times x minus x value, which is 0, right? Then we just solve it for that gradient intercept formula. So we want it in this format. So we have y equals to 2x plus 1, right? And that's all we'll have to do for that. Right. Moving on to the next one, find the equation of the line with the gradient of minus 3 and passes through the point 0, 4. So gradient of minus 3, again, write the equation. 4 equals, actually I'll write the full equation. y1 mx minus x1 y minus 4 equals to minus 3 times x minus 0. And then we just solve it for that formula again. So y equals to minus 3x plus 4. Right? And that's the equation. Just a quick point on parallel lines. Two lines are parallel if their gradients are the same. And parallel lines never intersect, so they never touch. So if we have this here, so we have y equals 2x plus 3 and y equals 2x minus 4 are parallel because they have the same gradient, right? And that's all that is for this topic, right? We'll get into some more questions in the next videos, but make sure you master this and then move on. See you there.